Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge. Minimum falling path sum. Given an n cross an array of integer matrix, return the minimum sum of any falling path through the matrix. A falling path starts at any element in the first row and chooses the element in the next row. That is either directly below or diagonally left or right. Specifically, the next element from position row comma column will be row plus 1 column minus 1 or row plus 1 column or row plus 1 column plus 1. Basically here if you see, so this row plus 1 just next and column minus 1 basically the rightmost, row plus 1 and the column just the downward, and row plus 1 plus column plus 1 basically the diagonal one. So here you can clearly see whatever it is mentioned. So we are required that falling path, um, that we are required to return the minimum sum of any falling path through that matrix. Now in this example one, here you can see that this matrix which is given. So here the output is 3. The basically the minimum sum is 13. So there are two falling paths with the minimum sum as shown. So if we see that, um, if we start from, basically we start, and here if we see, then if we go downwards and then towards the left, and here if we go down, 1 minute, here if we see we go down and then towards left and then here right and then left as per the falling path which is being given, means starting from the top and going towards down, either through going towards the left direction or towards the right direction. The basic thing is that we are required to check that what is the minimum sum which we can obtain. So that is the thing, means there could be any path which could be there, but out of all those paths we are required to check for the minimum sum. So now if we go ahead with this second example which is there, so here the things are in negative, and even if we go ahead either here or if we go here, it's 1 minute, if we go down or if we go here, so anyhow we are required to check for the minimum possible which could be there. So now, as per the constraint which are pretty much low, so we can go ahead with n square solution or even more than that. But as it is a metric, so yeah, n square solution is the minimum which would be required to be done in this particular. So now let us go ahead with the solution for the same, that how we are required to go. So here, first thing I'm just checking, means I'm just taking rows and columns count, and columns here I'm checking as per the things which are mentioned here. So column, if it is equal means I'll take I'll take this one, else my column could be 0, that is the thing, or I j k, and then result here I'm storing it to max because we are required with the minimum possibility. So that is the thing here. Now the next part which is there, okay, 1 minute. See, this is a row and this is the column. A column, if it is equals to rows, then fine, I'm taking this, else I'm taking as 0. That is the thing. And then I'm just defining this I, j, and k. That is all. And now comes the next part. That first I'll checking that if row is equals to 0 or column is equals to 0, then that surely means that minimum sum could be 0, right? Because we are required to return a positive value here. Now we will be iterating for the rows and columns which are there starting from the 1. For the rows and for columns we are starting from the 0 because we are required to start, means here we are checking for that second, uh, here we are basically required to check, means column which are there and rows which are there. So this, um, 1 comma 0 which would be there, from there we are checking for the minimum possible sum which could be there. And now here first thing we will be checking, about the previous one, right? That whatever is there means in the previous row, whatever is there at that particular column. And then for the fact that j is greater than 0, then we will be checking for this j minus 1 as well. That is just for the fact that we don't get any runtime error. Just we are required to acquire the starting position itself, which is there. It should be the minimum out of all those. And then here for this part, we are checking whatever is minimum out of this means whatever towards the left and whatever towards the right, which are there. Out of both of them, what are the minimum that we are taking here. And then we will be simply adding up to the present position which is there with that minimum. That is what we are doing here so that we can acquire the minimum sum which is possible. And now next we are going ahead with the columns, and in that all we are going ahead that whatever was being stored from those columns in starting from 0 till that particular columns, so out of that whatever minimum out of those would be there, that we will be storing, and at the end we are returning that result. So this is how we are doing this particular question. If you have any doubt, you could comment that down. And now comes the part for the time complexity and the space complexity. So here you can clearly see the time complexity as per this is order of n square, the row and the column counts which are there as per that. And here it is just order of n. So the overall time complexity becomes order of n square, and the space complexity which is there. So space complexity here we are not using any extra space, so space complexity is as it is order of 1. So because what we are doing is we are making changes in the input which is given to us, so that's why we are not using any other extra space. So that was the thing here. So this was all for this particular question. If you have any doubt, you could comment that down. And if you really like the explanation, you can like, subscribe to my channel and share this video among your friends. So this was all. Thank you.